Hi guys, welcome to the fourth video of books for M.sc Mathematics. In the last three videos, I show you the books for semester 1 and also explain what will be the subjects for semester 1. Also told you that for 95% of the universities, the subjects which are in semester 1 will be continued in the semester 2 as paper 2. Okay, for 95% universities. So in semester 1, what were the papers? Abstract algebra, topology, real analysis, complex analysis, and differential equations. So for 95% universities, all of these 5 papers will be continued in the semester 2 as paper 2. That means in the second semester you will have paper 2 for abstract algebra, you will have paper 2 for topology, we will have paper 2 for real analysis, we will have paper 2 for complex analysis, and we will have paper 2 for differential equation. But for few universities, like for 5% university, you can say the differential for 5% university differential equation is replaced by classical mechanics. Okay, only for 5% universities, and for classical mechanics you can refer to the book of D.S. Mathur, which is a very good book, which is full of examples which often come in university examination. Okay, so you can refer that book. And in the last video, I forgot to show you a book that I will be showing now. That is also for complex analysis. Okay, this book is for complex analysis. It is written by J.N. Sharma. This is a very good for complex analysis. It is very good book for complex analysis. It is full of examples which often come in university examination, and this book is very easy to understand. And this book covers both the semester 1 and semester 2 paper. Okay, so you can buy this book. This is a very good book. You can say this is an outstanding book. In last video I forgot to show you these books. I already show you 2 books for complex analysis in my previous video, but I just forgot to show you this book. So I am showing you this book in this video. Okay, also in my last video that I told you that to understand abstract algebra and topology, you should have very deep knowledge in set theory and functions. If you don't have knowledge in set theory and function, then you cannot understand a single line of abstract algebra or topology. To understand abstract algebra and topology, if you want to understand a single line of abstract algebra or topology, you should have good knowledge in set and functions. And for that, what I told you that I will be going to upload some notes for set theory and functions, so that you can brush up your knowledge, which will help you to understand abstract algebra and topology. So in this video, I will be going to upload notes for set theory. Keep in your mind that my aim is not to impart you training on set theory or function. Okay, I am uploading this because without knowing that, you cannot understand abstract algebra and topology. So, and also when you will be going through that note, you can brush up your knowledge. Okay, so let me start that. Okay, so you can see the title, that set theory to understand abstract algebra and topology. Again, I am repeating, without knowing set theory and function, we will not be able to understand abstract algebra and topology. So please brush up your knowledge. At least keep all these things in your mind. Whatever I am going to show you in this video for set theory, and I will be showing, I will be imparting training on function on the next video. Please at least keep all this in your mind, else you will not be able to understand abstract algebra and topology. And I have told you that once I complete these videos, I will be going to upload questions and answers for all of these 5 subjects. Okay, that is for abstract algebra, topology, real analysis, complex analysis, and differential equation. And those questions often come in university examination. Those are the type questions which often come in university examination. So to get the latest update, please subscribe the channel. Okay, so that you can be notified whenever I upload those videos. So what is set? Set is a collection of well-defined object. Okay, so for an example, all the alphabets in English. Okay, so what is not a set? all the flying birds in the sky is not a set because that is not well defined. All the fishes in the sea is not an example of set because those are not well defined. Okay, so alphabets are well defined. You know there are 26 characters in alphabet and those are well defined. That is why we can make a set of alphabets. Okay, so alphabets is a set. Now how set can be written? Set is written like this. Within these two curly braces we write the member of the set. So A to Z are the member of the English alphabets. So we write within the curly braces. So if alphabet is a set, then it can be written like opening curly brace, then all the members A to Z, then closing curly brace. So that is how we represent the set. In this way we can write this set. Okay, even vowels also belongs to set. Okay, because vowels is also well defined. We know A, E, I, O, U belongs to vowel and this is well defined. So that is why we can make a set of vowels. Okay, we can make a set of alphabets, we can make a set of vowels, but we cannot make a set of all the flying birds in the sky or all the fishes in the sea. Okay, because those are not well defined. But we can make set of alphabet and vowels because these are well defined. Okay, depending on how many elements a set has, it may be definite or indefinite, or you can say finite or infinite. There is no difference in terminology in between finite and definite and infinite and indefinite. Okay, so you can call it finite, you can call it definite, you can find it infinite, you can call it indefinite. Okay, so depending on how many elements of a set has, it may be finite or definite or infinite or indefinite. Okay, so what will be the example of finite sets? Finite sets we know that where this set starts and where this set ends. Okay, like for alphabets we know it starts from A, it ends at Z. For vowels we know it starts from A, it ends at U. Or we know only A, E, I, O, U are the members. Okay, and what is indefinite set? For indefinite set we may know the start. Okay, but we will not know the end. That because if you consider natural numbers, set of all natural numbers, we know it may start with it will start with 1, but we don't know where will it end, because it can be 1 million, it can be 10 million, it can be 1000 million, 1000 million. So we don't know where it actually ends, but it is well defined because natural numbers are well defined. So we can build a set of it, but it will be an indefinite set or infinite set. Okay, because we don't know the end. Okay, but yes, natural numbers are well defined, so we can make a set of natural numbers, but we don't know that where it will end. So that is why this is an infinite set or indefinite set. Even all, if we make a set of all even numbers, we know it will start with 2. Okay, but we don't know where it will end. So this is also infinite set. So what is finite set, what is infinite set, I think you have understood. So let me go to next page. So what is subset? If A and B are two sets and each element of A is also a member of B, then we say that A is a subset of B. Okay, and it is denoted by like this. It's denoted like this: A subset of B. For an example, we can say vowels are subset of alphabets because all the characters that belong to vowels, okay, also belong to alphabet. Okay, so we can say vowels is a subset of alphabets. Okay, now what is proper subset? If A and B are two sets, then B is said to be proper subset of A. If B is a subset of A but B is not equal to A, like vowels are proper subset of alphabets because all the character that belongs to vowels also belongs to alphabet, but the set of vowels is not equal to the set of alphabets. Why not? Why not equal to? Because vowels has only 5 characters, but alphabet has to set of vowels have only 5 characters and set of alphabet has 26 characters. That is why vowels and alphabets, set of vowels and alphabet are not same, not equal, but vowels are whatever character, whatever member are in the sets of vowel are also the member of alphabets. So vowels will be subset of alphabets, and vowels will be proper subset of alphabets. Okay. Now, what is power set? What is power set? If A is a set, then collection of all subsets of A is called power set of A and is denoted by PA. And if A is a set and n be the number of subsets of A, then it will be represented like this: P, a function of P within the bracket A, and then the modulus sign, and then 2 to the power n. Okay, so this is a power set of set A. This is a power set of set A. So if you consider alphabets, you can make lots of meaningful words from the alphabets, right? So whatever meaningful word we can build from the alphabets, you can make it. Then what will be the power set of alphabets? Power set of alphabets will be the here n will be the number of meaningful words that you can build through the alphabets. Okay. Now, universal set. A set is a set which has elements of all the related set without any repetition of element. Okay. A set which has elements of all the related set without any repetition of elements or members. Say if A and B are two sets, and A has member 1, 2, 3 and B has member 1, A, B, C, then the universal associated set will universal set will be 1, 2, 3, A, B, C. So for vowels and alphabets, you can say that alphabet is the universal set of vowels, or you can say that alphabet is the universal set of all the meaningful words, all the meaningful words in the world. You can say that alphabet is a universal set of all the meaningful words in the world. Okay. Now, what is complement? Complement means set of all elements which not contained in the set. Set of all elements. What does that mean? Complement means the members of a set which are not the member of the particular set. For an example, let me give you the example. So, complement of set of vowels will be the set of consonants. Right? Why? So complement of set of vowels will be the consonant. Why? Because in alphabets there are 26 characters. In vowels there are 5 characters: A, E, I, O, U. Now, what will be the complement of the set of vowels? Complement of the set of vowels will be the set of those number of characters of alphabets which does not belong, which are not A, E, I, O, U. So if we subtract A, E, I, O, U from alphabets, the rest of the characters are called consonants, right? So the complement of set of vowels will be the set of consonants. I have written it. You can please take a screenshot of this, because these all things are necessary to understand abstract algebra and topology. Now, what is union of sets? Union of set means all the member that are member of all of the set. All union means all the members that are members of all of the set, but members should not repeat, right? In set, member never repeats. Okay. So if we union vowel and consonants, then we will get alphabets, like vowel A, E, I, O, U, consonant all the characters except A, E, I, O, U. Now if you union that, then what we will get? We will get A to Z, that is set of alphabets. Okay. Now, what is intersection? The set that contains all the elements are common to both sets. Intersection means the common thing, okay, the common things, like if we intersect if we have an intersection of set of vowels and set of alphabets, then we will have the result will be only set of vowels, because in the set of vowels and in the set of alphabets, what things are common? Only common things are vowels, that is A, E, I, O, U. So if we do a intersection, okay, of set of vowels and set of alphabets, then the result will be the result of the intersection will be the set of vowels only. Okay. Now, what is null set? It is the set containing no element. It is also called empty set. Let 5 be an empty set. Then what is now if we do an intersection? What intersection do? Intersection does. Intersection take the common element from the sets, right? If you have two sets, I have given you the example vowels and alphabets. If you intersect them, we will only get vowels. Now, if we intersect vowels and consonants, you know, vowels only contain A, E, I, O, and U, and consonant contains all the characters except A, E, I, O, U, right? So there is nothing common in those, right? There is nothing common. So in these two sets, we will get nothing common. So what the intersection of these two sets return? It will return empty set. It will return an empty set, which is called null set. Okay, understood? Now what is the difference? Set of all elements contained in a set A but not in B is not set of all elements contained in a set A but not in B, and is denoted by A by B. So what will be difference? Now let you give an example. If we have set of alphabets, and if we subtract that from the set of vowels, what we will get? Consonants, right? So the consonants, what consonants are? Consonants have, consonant does not have vowels, okay, but consonant belong to alphabets. Even consonants is a subset of alphabets, right? Vowels and consonants both are subset of alphabets, right? But if we make a difference of set of alphabets and vowels, we will get only consonants. Okay, we will not get the vowels, right? So that is the definition, that set of all elements contained in set A but not in B. Okay, that here A is alphabets. Okay, A is alphabets, B is vowels, B is the set of vowels, and if we make the difference, we will get set of consonants. Now there are few operations related to set, so please keep all this with you to understand topology and abstract algebra. If you don't understand these things, if you don't remember these things, you will not be able to understand abstract algebra or topology. Okay, so now the operation of union and intersection satisfy the following properties. One is commutativity, another is associativity, another is distributivity, and another is idempotency. Okay, so what is commutativity? Commutativity is if A union B, then A union B will be equal to B union A. That means set of two unions. If we do union of two sets, it will not matter which value will be the left side and which set we should keep in right side. Whatever side we keep the sets, it will give the same result. For intersection, the same thing. For associativity, we can say if A union and B union C, then A union B union C. Okay, and the next one, what is A intersection B intersection C, then A intersection B intersection C. So these are the properties. I am not giving you the proofs because my aim is to give you those things which are very much required to understand abstract algebra and topology. My aim is not to impart you training on abstract algebra on function and sets. Okay. So what is distributivity? Distributivity is if we do A intersection B union C, then it will be written as A intersection B union A intersection C. And if we do A union B intersection C, then it will give the result A union B intersection A union C. And idempotency, what is idempotency? If we do A union A, I mean if we do alphabets union alphabets, we cannot write the members of the alphabets twice, so it will give the only the set of alphabets. So that is A union A. What is A intersection A? What will be the common? If we do intersection of sets of alphabets, we will get everything common, so it will return the set of alphabets. Okay. And the last one is De Morgan's law. What De Morgan's law says? De Morgan's law says if we do A union B complement, A union B complement is equal to A complement of A intersection complement of B. And second law, if we do A intersection B and take its complement, then what we will get? We will get A complement union B complement. Okay. So this is all about the set theory that you require to brush up to understand the abstract algebra and topology. So please brush up things. Okay, whatever I seen in this video, please brush up those things to understand abstract algebra and topology.